Okay, I want to do a little recording for you guys with a test lung. We're going to be changing compliance and resistance on these two lungs that we've got here. Resistance, remember, lives in the airway. So we've got some resistance here. I've got very little resistance in this one. But we're going to be able to do some analysis here of mechanics of breathing. So what I'm going to do is I'm going to ventilate this test lung. I'm going to use a resuscitation bag. And as I squeeze the bag, you're going to notice a couple things. Oh, excuse me. You're going to notice that pressure goes up. Got a pressure manometer right here, and it's indicating right now about 35 centimeters of water. And we've got volume that's measured on the scale in the back. So if I give a volume, I'm going to try to give a volume of 1 liter, and that's taking about 50 centimeters of water pressure. So we can calculate compliance based off of that. So we've got 1,000 milliliters. Oops, that looks like 1066. Per 50 centimeters of water. And if you do the math on that, you're going to come up with a value for compliance, right? So let me see, if I do that, we're going to have a compliance value for that lung that is 20 milliliters per centimeter of water. So that's where I scratched out that math, and hopefully I did that right. Looks right to me. So we're going to compare that with the other lung. Hook my resuscitation bag up. I'm going to squeeze in a value of 1,000 milliliters and read my manometer, and it looks like I've got about 18 centimeters of water there. Actually, if I get up to 1 liter, pretty close to 20 centimeters of water. So I can do a compliance calculation for that lung. And the compliance that I get when I scratch out the numbers on that lung was a compliance of 50 mils per centimeter of water. So the volumes were the same. It took a lot more alveolar pressure change because we've got change in volume over change in pressure. So I've got a much higher compliance in this other lung on the left. So again, if it's more compliant, it takes less pressure to give the same volume.